Assalamualaikum and hi everyone. In this video, we are going to present about energy application of electromagnetic radiation using method laser ablation from group 7.
This is our team members.
My name is FARAH ADIBA, BINTI ZAINUDIN. My metric number is 1211103. So, coupled model electromagnetic and heat-on nanosecond laser ablation is an application that integrates the behavior of electromagnetic waves with thermal effects. The electromagnetic model generates an intense electromagnetic field, which this field interacts with the electrons in the materials, leading to processes like multi-photon absorption, avalanche ionization, and electron-phonon coupling. The intense EM field generated by the laser pulse causes in rapid heating of the material, leading to thermal expansions and phase changes. This model approach based on Ohm's law, which is V equal to IR. The difference between plasma formation, ablation, and conventional heating of materials depends on the duration of laser action. In this case, two processes were responsible for the laser-induced damage of the materials. First is ablation by high-power laser-induced multi-photon ionization. Second is heat conduction and thermal explosion based on absorption by the impurities occurs. The surrounding metals particles are in contact with the air, and then the ultra-short pulse laser acts as a heat source and lead to a rise in the temperature. So this is the diagram of the flow chart for the coupled model of electromagnetic radiation and heat-on nanosecond laser ablations. After irradiation with the high-fluence nanosecond laser, the electromagnetic field was first calculated until the field reached a steady state inside the object. The power which dissipated because of ohmic loss was then calculated based on the equation P equal to JE, which was then applied to the heat transport equation as the heat energy transfer rate. Once the desired simulation time was reached, the simulation was stopped.
Okay, now let's look at the introduction to laser ablation. What is laser ablation? Laser ablation is the process where a laser beam is focused on a sample surface to remove material from the radiated zone. The term laser ablation is actually to emphasize the non-equilibrium vapor or plasma conditions created at the surface by intense laser pulse to distinguish from laser evaporation. Laser ablation is the process of heating and evaporation of material in condition of thermodynamic equilibrium. Laser beam considered and used for many technical applications, including the production of nanomaterials, routine welding, bonding of metal parts, and so on. It also provides a high precision tool for manipulating the structure of matter in a top-down manner. It excels at creating micro and nanoscale features on a material surface. By selectively removing material with the laser, researchers can create intricate patterns, grooves, and holes. It also uses high-powered laser beam onto a material surface, causing the materials to vaporize or break apart due to the intense heat. This allows for the precise removal of a material at a microscopic level.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is MOHAMED YAFIQ and YUSOF. Meeting number 1211097. So I will present about the working principle of the laser ablation. So there are two steps. The first step, the amount of the light emitted to the material by using the laser pulse is illumination. So the small part in the material will be absorb the photon energy and cause the heating effect of pulse. So from the heating effect of pulse, the material decompose into the two things, atoms or ions. So next we go to the second step, which is the free atom will be undergo cool down steps. It's really rapid due to the large temperature gradient. So the active atom assembled together and redeposited huge ultra small sphere, and it will form the defect due to substance loss. And lastly, thin layer at near surface decompose and redeposited.
Hi, I'm ATIQAH ZULKIFLI. My metric number is 12102. Now I will proceed with characterization of the produced sample. There are 5 analyses used to characterize the sample. The first one is by using wavelength analysis. This analysis focuses on the optimal laser wavelength, which is 1064 nanometer, for producing nanoparticle and analyze the effect of different wavelengths. Second, temperature analysis. This analysis uses thermal-gravimetric analysis (TGA) to observe its thermal stability and decomposition temperature. Third, energy fluence analysis to determine how much energy is delivered to the material surface. Next, laser damage testing determine the damage threshold at the melting point, while pulse duration analysis study how shorter pulse duration lead to higher peak power and localized temperature rise, affecting the ablation rate and material removal per pulse.
My name is Hanani binti Muhammad BAKTIAR, metric number 1211107. Specific characteristics for the intended application. First, wavelength. The wavelength of the laser beam determines the depth of penetration into the materialized effects on nanoparticles. Shorter wavelengths are absorbed more strongly by materials and can be used for more precise ablation. Next is pulse duration. Pulse duration of the laser beam is the rate of ablation. Shorter pulse durations can produce higher peak powers, and that can lead to more material removal per pulse-specific configuration. Next is repetition rate. It refers to the number of laser pulses delivered per unit time. Heat accumulation. At high repetition rates, the target material doesn't have enough time to cool down completely between pulses.
That's all from us. Thank you for watching, everyone.